Okay, question number 8. Elisa needs money to repair her home air conditioner, so she pawns her bicycle. The pawnbroker loans Elisa $270. Okay, her the loan principal is $270. 10 days later, which is 10 time is equal 10 days, Elisa gets her bicycle back by paying pawnbroker 283, which means principal plus interest, right? It's going to be 283.5. I will rewrite all this. So we need to find the annual simple interest, which is R, and we consider 360 days in a year. Okay, let's work on it. So, what do we have? Our principal is borrows $270. I don't like this. This is too. Okay, $270, and for the 10 days, well, days we need to convert into the year, which is gonna be how much? 10 over 360 days, right? We need to convert to years. So, and in 1 year, 360 days. Banks count 360 days. And that's going to be 1 over 36. Okay. What else we have? Yes, borrowed 270, returned, meaning with interest, principal plus interest, was equal to $283.5. We need to find annual interest rate. All right. So, if we have loan plus the interest Elisa paid, it's 283.5. And we have the loan amount is 270. So from here, I can find out interest, right? That will be equal 283 and half minus 270. That is going to be $13.50. She paid the $13.15 interest, dollar sign. $13.50. Okay, we have time. Now let's go after formula. I is equal PRT. We have I, we have P, we have T, we don't have R. So to find R, this is like in algebraic the equation, R will be our X, right? So since all multiplication, so I'm going to divide by P and T to get rid of them, right? There we go. And whatever change I do to one part of equation, I have to do same change to the other part of equation. And from here, to rewrite clean, R, which is rate is gonna be equal I interest in dollar amount divided by loan times time. So interest is 13.5 divided by principal 270, and time is going to be 1 over 36. So multiplying 1 over 36, it's going to be, let me see, 13.5 how much we're gonna do. Let's do the math the portion. If I do math, it's going to be 270 times 1, and 36 come up because you have to flip the fraction, right? Practically what I am doing, I'm taking 13.5, I divide by 1 over 36, which means I can flip, right? Division by fraction, meaning multiplied by flipped fraction. Okay, and let's do operation. We have 13.5 times 36. I'm getting 486 divided by 270 and getting 1.8. 1.8. That's a decimal notation. And to get a percentage, R is going to be equal 1.8 by 100 multiplied by 100, right? Because 1.8 decimal, and it's going to be 180%. Gee. Okay. 1 and 2 position, right? Adding 0. 180%. So 180% is going to be our answer. Let's type it in. Okay, very good. Moving to question number 9. Let's see what we have in question number 9. So, use the compound interest. Okay, this is the interesting thing. All this time we were working with simple interest. Now we are going to work with compound interest. What means simple interest? What means compound interest? Let's say every month your interest is $5. So from principal amount that you left to pay. So let's say that you borrowed $100. Okay, first month you paid $5. Principal payoff $10, $5 out of which is your interest. So you have left another $5 towards principal. So you have $95. So this $5 always gonna go from the balance. Okay, while compound, it's gonna accumulate. Let's say a daily 1%. So today I borrowed money. Today 1%. I will pay every month at the end of the month, but my interest accumulated every day. So I have two choices. I either can pay every single day, okay, or I can pay at the end of the month, but that will be compounded, which means let's assume I borrowed $100 and every day the interest going to be $5. So today will be $105. Tomorrow it's going to be another $5, $110, and then $115, $120. It's compounding, it's accumulating, and at the end I will pay cumulative amount. While simple, it's every day from the same 100 and then from 90, from 85 and so forth. Okay? That's the difference between compounded and between simple interest. Okay. So let's see what we have here. Use the compound interest formula to compute the total amount accumulated by the accumulated and the interest earned. So let me take a picture of this data so we can start solving. All right. So we have, what do we have here? Our principal, we are borrowing $7,000. Okay. Our time is, let me see, 3 years. Okay. Time is gonna be 3 years. And 3% compounded daily. Okay. R is gonna be 3% compounded daily, which means 3% is going to be 0.03, and since it's daily, I have to express in a year. If one day is 0.03, in a year we consider 360, so we divide by 360. If we would have quarterly, then I would take 0.03 divide by what? Quarterly, right? 4 times. Okay? All right. So what else? Daily, and use N360. Okay, we have it. Now, the formula for compounded the amount is equal. A is equal principal times 1 plus R over N to power NT. So let's write down, and I will explain as I write down. We are going to have principal, it's going to be 7,000. Oh. 1 plus R over N. N is an amount of terms. In our case, it's going to be, since it's daily, 3%. So we divide by N 360, right? This is a term that we are counting, which is going to be 0.03 divided by 360 to express in a year. And then raised to power N, and our N is 360 because we are doing this daily, and times T. How many years we have? We have 3 years, right? Times 3. Okay, since we have daily base, then we convert 3 years also into daily base. So 360 times 3. Okay, well, let's solve it. How much it's gonna be? This is gonna be equal. I'm going slow because it's a lot of small numbers calculation. 1 plus, and we are not rounding till the end, guys. Okay. Um, 0.03 divided by 360 and plus 1. I'm getting here 1.00833333 to power 36 times 360 times 3, 0, 3 times 6, 18, 1 in mind, 3 times 3, 9, and 1, 10. 1080. Okay, so I'm going to flip my calculator in my iPhone. It becomes scientific. Turn it horizontally, it becomes scientific. And this number 1008 and whole 9 yards, I have to raise to power 1080. I'm clicking on key x to power y. X will take as a 1.00833 blah blah blah, and now after that I push the button 1080, and I am getting here let me see, 7,000 times Why should I get 7,000? 1 to any power, it should get very little. Hold on, let me try one more time. 1.08, oh, hold on. 1.008, 1, 2, 3, 4, 5, okay? Raising to power 1080. I'm getting 7,000. I don't like it. It's that's kind of wrong because it's approximately, this is approximately 1. 1 to power 1,000 or any power you raise, it should be 1 and a little bit, right? But I don't know why I'm getting, hold on, let me do this way. I'm checking 1 to power 1,000. Okay, got 1. Okay, very good. 1.008, 1, 2, 3, 4, 5. I am not rounding anything. Raise to power 1080. I still get the same thing. That's weird, very weird. 2 to power 3. Let me check. Yeah. Okay, well, let's see where it will take me. 1.008, 1, 2, 3, 4, 5. Okay, raised to power 1080, and I'm getting 7,806 and then 433 blah blah blah. So I need to multiply by 7,000. Yeah, I'm getting huge numbers. Something is wrong. Let me double check again all this calculation. Okay. 0.03 divided by 360. Okay, this is gonna be, oh, looks like, oh, I see. Okay, I see. 0.03 divided by 360, there are much more zeros. 0.03 divided by 360. That's okay, I see. Found it. This division, I had to have much more zeros there. Okay, this is going to be how many? 1, 2, 3, 4. 1, 2, 3, and then 4. Here is 1. That's what it's gonna be. And then plus 1. Yeah, I'm getting 1.1, 2, 3, 4 zeros, and okay. Now this I'm raising to power. Oh, I raised the wrong one. Pushed the wrong button. Hold on. Yeah, I raised cube. Okay, hold on. It's not a big deal. I'll write down one more time. 1.12348 3 3 3 3 3 1 2 3 4 5. Okay, pushing button x to power y, and then pushing 1080, and now I got it. Times 1.09417011414. It's good enough. And time, so let me multiply by 7,000, and I'm getting, okay, we got it. Okay. $7,659.19. Okay, let's write down. Total amount accumulated after 3 years is going to be 7,659.19. Nice work. So, moving to question number 9. Oh, second part of it, okay. What is here? Second part, the amount of interest earned. Okay, the amount of interest. What we are going to do here, so this 7,659, that's a principal plus interest. Yes, principal plus interest. So from here, I'm going to take that 7,669 and subtract our original 7,000, because we put 7,000, got back 7,006 in 3 years became 7,659. So let's solve it. 7,659 minus this 7,000, because I borrowed 7,000, right? And we are getting 659.19. $659.19. Okay, bingo. Moving to question number 10. What do we have here? It should be something similar again or not, we'll see. So let's read it. Use the present value formula to determine the amount to be invested now or the present value needed. Okay, what is it is about? It's about how much, see what it says. The desired accumulated amount is $40,000 after 10 years invested with 6.2 interest compounded monthly. Here is the question. If you want in 10 years, you have $40,000 with 6.2 annual interest, the interest compounded monthly, how much you have to invest now to get 40,000 in 10 years? That's what it is about. So let me write down data. Principal is 40,000. Okay, time is 10 years. And rate is 6.2% compounded monthly. All right. So, from the formula that we use, this formula for compounded interest, PRT we use for simple fixed interest. But for compounded interest, we are using this formula. And from here, so we need to know, we have this, we want to get 40,000. How much I have to invest now to get 40,000? Okay, so we need to find this P. From the formula, this P is going to be equal accumulated data divided by 1 plus R over N to power NT. Okay, let's go. So what do we have? P is equal. Let me write down here the data we have. So my accumulated data is going to be, how much it is? $40,000. Okay. What else do we have? R is 10 years. Okay. Hold on. 10 years compounded. Oh, T is 10 years. Okay, let me write down T is 10 years. Well, taking pictures is working much better than writing. And then interest is 6.2. So interest is 6.2%. Okay? So, compounded monthly. Well, let's see. P, the present value that we are going to invest to get 40,000. This is going to be 40,000. A is our 40,000. And then we divide 1 plus our rate is 0.062, right? 0.062 divided by n. Since it's monthly, right? And we need to put annually, every year is 12 months. So we are going to divide by 12 this. And raised to power n is going to be 12. And t is 10 years. Was it 10 years? Let me double check. Yes, 10 years. Very good. Okay. So times 10. All right, let's solve it. So 40,000. Let me solve it. 0.062 divided by 12. I'm getting 0.005 and blah, blah, blah. Plus 1. Okay, 1.005. This is I'm getting 1.005, 16667. Okay, now let's raise to power 120. Pushing button X to power Y. And 120. And I'm getting 1.8555 or something like that. So 1.85596,324. 1414. Okay, enough. This much. Let's do it. So 40,000 dividing by 1.85596,32414. And I'm getting 21,552 and 15. So I have to invest now, let's say 21,552 with 10 years. For 10 years with interest 6 point, how much? 6.2. So in 10 years it will become $40,000. All right. So I put here the present value is going to be 21,552 till recent cent. Okay, decimal notation. It's gonna be dot and 15. Excellent. Moving to question number 11. Let's see what we have next question. So use the present value formula. So it's the same thing to determine the amount to be invested now or the present value needed. Let's work on it. Let me take a picture. So I am investing, or whoever is invested. Oh, I can clean this data. So desired amount I want to get this time 150,000. Okay, it's gonna be after 2 years, it's gonna be 2 years. Interest is gonna be 3%. Compounded quarterly this time. Okay, so it's gonna be 3%, it's gonna be 0.03. All right, let's plug the data and see what we are going to get. So we have desired amount is 150,000, right? Dividing by 1 plus our R is 3%, 0.03. Since it's compounded quarterly, how many quarters are in 1 year? 4. Dividing by 4 and raising to power n, which is 4, and t is 2 years. Okay, let's solve it. 150,000. So where is my calculator? So 0.03 divided by 4, 0.0075 plus 1. I got 1.0075. Now I'm raising to power 4 times 2, which is going to be 8. Okay. Raised to power 8. And I am getting 1.0615884781827 the whole 9 yards. I wrote down because look, numbers are pretty high, and when you round it's going to keep rolling, accumulating numbers to higher. Okay, so now 150,000 dividing by 1.06158847818,275. Oh, doesn't take more. Okay, well, that's good. And I'm getting 141,296.31. Okay, let's write down. So this is going to be 141,296.311. Okay, 31. It has 2 decimals. It's asking nearest cent. Nice work. Okay, number 12. If the problem is similar, then I will not solve it, because you can solve it the same way. But let me see. A theater invests 1,500 in 18 months. CD player 2.4 interest compounded monthly. Okay, I'll give you guidance maybe on this one. So let's write down. I'll write down all data and then you will be able to solve it. All right. So what do we have here? We have our principal is equal 1500 because it says to help pay for new consumers for a play, a theater invests 1500. Interest rate, this is dollar amount. Interest rate is gonna be 18 months, 2.4. 2.4% or 0.024. Okay. And time is n. Oh, okay. N time of periods. So it says compounded monthly, then n is going to be 12, right? 12 months in 1 year. N is 12 and time is how much time period it is? 18 months. Okay. Let's do it. So A is equal P times 1 plus R over N to power NT. So I'm investing 1500 now with 2.4% compounded monthly for 18 months. So how much money I will get in 18 months? So this is going to be equal 1500 1 plus 0.024 divided by 12 because compounded monthly, right? And raised to power n, we have 12 months. So actually 12 months times year is 12 months and we have 18 months. So 18 over 12, right? N is 12 and then 18 because we have 18 months. How much is 18 months? 1.5 years, yes? Okay, so either I can put 18 over 12 here or 18 months is 1.5 years. I can put that way. Let me put 1.5 years like that. Okay, let me solve real quick. 1500 times. So what do we have? 0.024 divided by 12, got 0.002 plus 1. I'm getting 1.002. And how much is 12 times 1.5? That's getting 18. So we have 1.002 times 18. I am getting 18.03. 18.036. Okay, let's multiply by 1,500 and I am getting how much? 27,054. I don't like this number. It's too kind of you can't put 1,500 get 27,000 with 2.4% in 18 months. Something We did something wrong. Okay, one more time. Let me do math one more time. 0.024 divided by 12, 0.002 plus 1, 0.002. Okay, so 12 times 1.5, it's gonna be 18. This is 18. So 1.002 times 18. Oh, to power 18. Gee, I'm multiplying, sorry. So 1.002 to power 18. No wondering I'm getting too much. Okay, so and then I'm getting 1500 times 1.036618 5 7 6 digits 1 2 3 4 5 6 7 8. Let me see if it will take it. Times 1500. Okay, I put one more additional zero. Okay, 1500 times 1.03661,857. Okay, now I got it right. So A is equal 1554.93 if I round it. So 1554.93. Pay attention on rounding. Very nice. And moving to the last question. Let's see what we have there. So, Karen invested 14,000 in a money market account with an interest rate 1.75% compounded semi-annually. Compounded semi-annually. For 4 years later, Karen withdrew the full amount to put towards the down payment on new house. Okay, how much did Karen withdraw from account? Right, let me take a picture. So let's write down. So our principal is, we invested 14,000. Okay, with interest 1.75. 1.75%. That's going to be 0.0175. Okay, now compounded semi-annually, which means n is going to be 2. It's every 6 months. Semi-annually, twice. And with the time period is equal how many times? 4 years. Okay, well, let's solve it. So how we invest 14,000 with under this condition with 1.75% interest, compounded semi-annually for 4 years. How much is going to be our money in 4 years? A is equal P times 1 plus R over N multiplied by raised to power NT. Okay, this is what we have, 14,000. 1 plus 0.0175 divided by 2 and raised to power 2 times 4. N is 2, T is 4. Yes? Okay, let's go. So 0.0175 divided by 2. Okay, 0.008 plus 1. I'm getting 1.00875 and raising to power 8. So let's raise to power 8. And I get 14,000 times 1.0721816,788. Okay, so times 14,000. And I'm getting 15,000 okay, I'm getting 15,010.54. Okay, 15,010.54. Okie dokie, we solved the last problem. See you in next homework.